So if you've already received both the code repositories, one for the blockchain access control server, which is right here, and the other for your Raspberry Pi, which is going to act as your it's going to act as your primary group head. I'm going to explain in a little bit what a primary group head is capable of doing. But this is going to be your access control server. You're going to need to deploy this code into a laptop or a small computer and install all the prerequisites. You have the documentation file that is necessary for you to get started with having the blockchain access control server at your end. But yeah, it has two components here. This is the front end for the blockchain access control server, which we aren't using at the moment, since we're interacting with blockchain directly through the network using our IoT devices, or in this case, first we're going to use a couple of primary group heads to perform basic network communication between these two devices and validate some of the access control through smart contracts. Now, the first thing is you go to this file path, and we are going to install, and I've already opened everything up here. We're going to, once the ganache and all the prerequisites are installed, which you can find it in the documentations, you can then run this code that would execute, or well, before I do that, whenever you do encounter this problem, make sure that you kill the service that is already in use. Once that is done, you can execute this command. Basically spins up the access control server using smart contracts. Well, we have the available accounts here and the private keys. And you can see that the RPC is listening over at port 8545. Now this is a port we're going to use for our primary group head to communicate with this blockchain access control server, right? So an important thing is to make sure both the devices are within the same network, and you have configured on the network level that there aren't any firewalls that prevent this port from being accessed within the system that you're using, or also make sure that this is available not just as a local host but also listening within the network as its local IP address. Once we get to this, this is where we start with communicating with the primary group head. The primary group head has the ability to interact with the blockchain access control server on behalf of all the IoT devices, and also on behalf of itself as a primary group head of the network, right? So this is how it's done. Basically, you have a sync to Pi script, and we have automated a lot of manual work here in some or the other type of script that would help execute everything that is necessary in order for the primary group head to be aware of the actions that it needs to take, or the data that it needs to contain to make the communication with the blockchain access control server. So we're just basically sending a lot of data, relevant, important data that the primary group head needs to utilize in order to talk to the blockchain access control server. And we're doing a bunch of stuff here. You can always read the documentation to understand in a bit more detail on what exactly this script is doing. But basically, we're sending out an important set of information like the ABIs and the private keys. These are basically the list of files being sent and being deployed on the right path for the Raspberry Pi, right? This script does everything pretty much by itself, so you don't have to worry about it. But I'll show you the step that you need to, like the command that you need to type in. First, you need to be on the file path. Sorry. Once you've done that, you need to enter the username of the Raspberry Pi and the private IP address that's there. That's going to be the Pi host address. And then you're going to go to the file path of where you've stored the repository. And then you're going to also enter the IP address for the laptop, where specifically we're going to append this with the port 8545 so that the primary group head is aware of the IP address it needs to communicate to make those exchanges with the blockchain access control server. And then at the end, we're just executing the sync to Pi script, which basically does everything that we need to do. Right. In this case, my local IP address for the Raspberry Pi or the primary group head is 1.199, and this is my local address of the laptop where I'm running the blockchain access control server. And I'm just going to press enter here, and this is where you need to specify the target PGH. So our setup has a possibility of up to 2 PGH at the moment for network testbed setup and for testing purposes. We can scale this as much as we want. However, for most of our scenarios, we usually have 2 PGH communicating with each other at most, and then it has a couple or a bunch of IoT devices connected to it. Now, we're going to select A. In this case, that's the first one, and by default, it selects A, considering it's the first primary group head of the network. Once you do that, basically, it does a bunch of stuff which we have automated. I have automated as much as possible, as you can see here. The deployment of the addresses, the running of Truffle, which is basically the interface used for managing or communicating with our blockchain access control server. Then we have contracts deployed for the blockchain access control server, which would be the admin contract addresses. And then we would have Bootstrap, which would then dump the relevant information like the keys that are generated by Ganache and the contracts that are migrated, and the environment file is refreshed. Now, an environment file is the most important thing here, because this is where all the relevant data is stored in order for blockchain access control to utilize the front end or any other devices to utilize blockchain access control's capabilities. Think of it as the configurations file for the blockchain access control server. So I need to type in so the script is also SSH, going to SSH into the Raspberry Pi, and then it's going to send the payload, which consists of all the data that it needs in order to talk to the blockchain access control server, and also it executes the payload to be stored on the specific file path where it needs to be. Right. So this is more or less most of the things that you need to do on the blockchain access control side. Of course, there's a bunch of prerequisite steps that you need to do, for which the documentations will be made available. But once that is done, you can see the contracts are right here. You have some JSON files to build those contracts. You've got some configurations. You've got documentations here, which you can use for deployment and runbook. You got the IoT code here. This is a local IoT branch, basically for internal testing purposes. However, in our case, we've already moved this to another, an actual Raspberry Pi, where I've done more development stuff in order to complete the interaction between these to devices. This is also where the script initially stores the environment files before it's being sent to the actual Raspberry Pi. As you can see here, this is an example of what a .env file looks like. It has the RPC URL to communicate with. The local host address is replaced with the private address for the network, for the blockchain access control server. There's the primary head key, then there's role token addresses, then there are a bunch of other addresses that it needs in order to communicate with the blockchain access control server. Most of these codes are relevant to the Raspberry Pi itself, so we're not going to talk about this here. We have some integration test file. These are just test files that were used for validating some of the features that are out there. What else do we have? So this is where temporary keys, as you can see here, these are all the keys that Ganache generated when we spinned up the blockchain access control server right here. And these are some of the transactions that have already happened. However, you can see here, these are the private keys, and these are the available accounts generated by Ganache. And we also have a couple of important stuff here. I mean, of course, blockchain front end is not that important, but you can take a look at some of the documentations that are here. But more importantly, this is everything that you need to know in order to get started. You just have to run the commands. That's how easy I have tried to make it for everyone, so that they can just execute these commands and be able to at least get started with the initial testing. Once we have already moved the scripts, now let's move on to the actual Raspberry Pi, and this is where the actual Raspberry Pi sits. Well, this is the screen. We've done a VPC. We've done a VPC to get into the Raspberry Pi, so you can see the screen right here. The first thing that we need to know is that you've got the .env file. As you can see, it's updated with the IP address and the port. This is where it's going to use, the RPC URL will be the point of communication for these individual primary group heads. This is where all the scripts are sitting. We have a bunch of scripts here. All of them are, somewhere or the other doing a full simulation of behavior interacting with the blockchain access control server, and then generating results for us to analyze and perform our research on. However, you have a doc/scripts file where you can basically, for example, run all on pi.javascript. So this script right here, what it does, how it does it, and all that kind of stuff is kind of explained here. The smart contract it utilizes, I think we have a better one. I think run all via PGH has a better explanation of what exactly it is doing, all the actions that it does in order, and then all the contract calls that it performs. These are all APIs that were developed for the Raspberry Pi to interact with the blockchain access control server. And basically, this is what the script does, and then generates the result. I will run a simulation to show you as an example. And we've already sent across all the relevant data needed for the Raspberry Pi. We have the Ganache chain running right here. So we have everything on the blockchain server side needed in order to now perform interaction with it. So first thing is that you start, you also need to install, if you're doing this for the first time, but if you're doing it for a second or third, or you've already done it a lot of times, you can just go ahead with starting the service. Here again, if you encounter problems with the address already in use, all you have to do is find the port and kill the process. And then once you start the primary grouped service, and I'm going to show you which service this is. This is the main JavaScript that has, yes, primary head.javascript. This is the whole head of, this is the core service that interacts with the blockchain. It has everything it needs in order to talk to blockchain on behalf of either the IoT devices or well, basically the PGH itself, right? It acts as a small server that it can, that it can use to communicate with both IoT devices and the primary, the blockchain access control server. Now, let's move on to executing one of the scripts. And for this, we're going to use run all via PGH. As you can see, we've got a bunch of scripts here, and all of these are designed to perform a full simulation across the network and then produce results which we can use for further analysis. I'm going to press enter here, and that's all we need to do. The script will run itself, and usually with a non-transaction error, it rotates the keys for us so that the simulation completes with success, and then the reports are stored in the results section. Okay, where are the results? Okay, here. So let me look at the timestamp to make sure if we are on the right place. Yeah. And yeah, there are two files here. The first is report. As you can see, it performs a register device with success. Every transaction has a transaction hash, which is basically a proof of the transaction happening without you cannot perform changes to that transaction. It in itself is hashed, so it's immutable. We register the device for the subject and the object, and once we do that, we deploy contract addresses. We have a policy. A policy is necessary for something to be viewed or edited by the device, right? Once we have the policies, once the policies are added, the accesses are given basically according to what the policy says. In this case, now we're evaluating access for view because view access was given to the policy. So the subject is able to access with view permissions on the object, and you can see it's a successful action. It's a type of action that is a positive behavior because it already does have access to perform that kind of action, right? So token adjustment is a +1. After that, you have a register object. I think this is for registration, object and subject. Again, it's going to perform a set of actions, transactions for the network. Currently, at the moment, it does not specify the gas used, or it does. It should be showing gas used here. So this is the main steps taken, and then there are the matrix. Oh yeah, so so this basically is the same data, but then it's interpreted in a different way. But then you can see here the gas used for it here for all the actions, and then you have statuses. These are system level statuses that, for example, like uptime, or if there were any errors, things like that. These are all different types of metrics being, how do I put this, collected, so that we are able to evaluate the performance of the simulation. The first simulation was pretty basic. We just, we validated successful action. We saw that the successful action to view an object that has been given access to view was allowed, but then we should also have a thread detected. Oh yeah. So basically this means that the action was, this isn't considered a thread. The event thread detected kind of is evaluating if a threat is detected or not. So in this case, it isn't a threat. We should have an example for a threat here somewhere. Okay, in this script, we're not really evaluating the edit access. So for example, if we had an edit action on this, but the policy did not have that action created. I mean, the policy was only for view access. Then in that case, it would be a malicious behavior, and basically it would be considered as a threat. The event code says threat detected because it's trying to evaluate if it's a threat or not, but the code successful access means that it was a legitimate access, in which case the subject was able to access the object with view permissions because it had permissions in the first place. There are other scripts that we can run to further evaluate it. The steps are going to be pretty much the same. The documentations are in place to cover everything that you need to run step by step. Once you have a better understanding of how these two major components interact with each other, we can then further discuss some of the other components of this network setup. We have an API, which basically is a server that orchestrates the IoT devices. And then we also have a dashboard that encapsulates all the IoT devices as well as the blockchain interaction. So it's a dashboard which has a view on both the major components that we need within the network. That is all. Thank you.